Okay, we're going to do some examples with rational exponents. Here are some problems with rational exponents. 8 squared, that's probably a little bit too easy for you. It means 8 times 8, right? 64. What about 8 to the 5/3 though? What do I do with something like that? All right, first thing to do is rewrite the 8 as an exponent itself. So that could be 2 to the 3rd to the 5/3. Now, do you remember your exponent rules? When you have a power raised to a power, what do you do with those? I hope you said multiply. So I do 2, and I'm going to put in a little think balloon here what I'm going to multiply. 3 times 5/3. You see what happens there? 3 over 1, 3's reduce. 2 to the 5th, 32. Final answer. So, there's a nice little example. What about this one? 49 to the -1/2. Okay, rewrite the 49 as 7 squared to the -1/2. So 7, and what do I put in my think balloon here? 2 times -1/2. That is -1. 7 to the -1. Final answer for this one, 1 over 7. I hope you remember from Chapter 7, we learned how to deal with negative exponents. Positive exponents, no brainer. Negative exponents, we can't use them until they are positive exponents. All right, let's take this one. 9 could be written as 3 squared to the exponent 1.5. Let's change that to a fraction. Do you know the fraction? 3/2. Power raised to a power. What do I do with the exponents? I multiply them. So let's put a little think balloon here. 2 times 3/2, 3 to the 3rd, 27. So that's not so bad. You can work with rational exponents. Important to always have your exponent positive in the end, or so that you can get your final answer. Okay, a few more examples here. Write in exponential form. What exponent would I use for this root here? So I have x, y to the 3rd to the 1/2. So this becomes x to the 1/2, y to the 3/2. Once I have this to a power, I carry it to both of those, right? Okay, what if I had 5th root of x squared y to the 10th? First thing you do, x squared times y to the 10th to the 1/5. Then carry the 1/5 over. I get x to the 2/5, y to the 10/5. Oh, neat! That reduces. So if something reduces, make sure you do it. So this would be x to the 2/5, y squared. That is exponential form. You need exponential form sometimes to solve problems. Cube root of 9 times square root of 3. If this was square root of 9 times square root of 3, you could multiply the 9 and the 3. But since the radicals are different, I can't do that. So I'm going to rewrite this. 9 is 3 squared. To what exponent? For the 3rd root. If it was 5th root, I used 1/5. So what do you think I'm going to use for 3rd root? 1/3. Okay? Times 3. What root do I use for a square root? What exponent? 1/2. All right, let's simplify this part. 3 to the 2/3 times 3 to the 1/2. If the bases are the same, I can add the exponent. So let's do a little think balloon here. I'm going to add 2/3 plus 1/2. So I need common denominators. So I have 4/6 plus 3/6, 7/6. 3 to the 7/6. And that's exponential form for that problem. Okay, in this one it says to solve. Again, can I multiply the 16 times the 8? No. So Let's write 16 as an exponent. 2 to the 4th to the 1/3 times 2 to the 3rd to what exponent? 1/2. Okay, so now I have 2 to the 4/3 times 2 to the 3/2. Can I add my exponents now? So I get 2 to the 4/3 plus 3/2. What do I do with that? Common denominator, right? So I get 8/3, 8/6 plus 9/6, so I get 2 to the 17/6. Now, sometimes when it says solve, can I leave it at 2 to the 17/6 when it says solve? If it starts in radicals, you need to put your answer back in radicals. So this is the 6th root of 2 to the 17th. Now, I can do some more simplifying on that one. 2 to the 17th is really 2 to the 6th times 2 to the 6th. So, to finish up this problem, let's move over here. So, I have the 6th root of 2 to the 6th times 2 to the 6th times 2 to the 5th. The reason I wrote it like this 2 comes outside. This 2 comes outside. I still have 6th root of 2 to the 5th. So, this becomes 4 times the 6th root of 32. And remember, if the problem starts with radicals, you shouldn't leave it as your answer in final exponent form. So this answer here wouldn't be appropriate since I can take some numbers outside and simplify as much as I can for a radical. You can do these. Good luck.